Welcome to Algebra Chapter 2, Section 2, Two-Step Equations. Our goal is to solve two-step equations using the inverse operations. As in single-step equations, we are trying to get the variable by itself, to isolate it. In two-step equations, you will see that sometimes it takes more than one step to do this. Here is the first. You tell me which of these equations have an isolated variable. Just write the 1, 2, 3, or 4 equations that have the variable isolated. Pause this video and do this now. I found two that had the variable isolated. 8 plus 4 equals W. There W is by itself on the right-hand side of the equal sign. And Y equals 3 minus 1/2. And Y equals 3 minus 1/2. The Y is on the left side of the equal sign and by itself. You do know equations. It comes back to you can do anything you want as long as you do it equally to both sides. But to stay away from fractions, you might want to come up with a strategy. Here's my strategy. Step 1, undo the addition and subtraction first. Then undo multiplication and division. This is the second thing I want you to put in your notes. A two-step equation involves two operations. You want to undo the operations in reverse order of the order of operations. So the part I want you to put in your notes is this part. Have the notes. Order of operation has you first multiplying and then adding. Well, to solve this, you're going to first undo the addition, then undo multiplication. So put this in your notes. Point should be this example. Point number 3, we're going to subtract 3 from both sides. We're going to undo the addition subtraction first. So we have 2x. These cancel, leaving us 15 minus 3, which is 12. Then we're going to divide by 2 both sides. Divide both sides by 2, so x equals 6. Now we need to check our answer. To check our answer, I'm going to take this 6, and I'm going to put it back in the equation in place of x. So I'm going to rewrite the equation, putting 6 in place of x. So 12 plus 3 equals 15. Well, of course, 15 does equal 15, so this checks out as a true equation. So x equals 6 is our solution. This is number 4 in your notes. Write this equation down. To solve this, you see that we have a t divided by 2 minus 3. Well, like in the last problem, we're going to undo the addition subtraction first. So we're going to add 3 to both sides. And this helps us stay away from fractions. So on the left we have 8. On the right we have t divided by 2. And minus 3 plus 3 canceled out. Now this is t divided by 2. T is not yet isolated. To do that, we need to undo the divide by 2. To undo that, we're going to multiply by 2. So I'm having 16 equals t. Notice what I did on the right, I had to do on the left. To check this, I rewrite the equation, but this time I'm going to put the 16 in where the t is. And then I'm going to solve using order of operations, which means divide first and then subtract. Since 5 does equal 5, I checked my answer and know it's true. Here's point number 5 to put in your notes. As you see, I have some fractions here. Now, many people don't like to work with fractions, and so I'm going to show you a way of getting rid of them. To get rid of the fractions, I'm going to multiply by a multiple of the denominator. So as a denominator, I have a 4 and a 2. To get rid of that, I'm going to look for something they both go into evenly. Well, they both go into 4 evenly. So I'm going to multiply both sides by 4. I can do whatever I want as long as I do it to both sides of the equation. So as I distribute this, I get 4 times 1/4 plus 4 times 1/2 x equals 2 times 4. These cancel. So I have 1 plus, again canceling, 2 goes into 2 once, 2 goes into 4 2 times. So I'm going to look at 2 times 1 is 2x, there's a 1 denominator, equals 8. Now I have a problem I can solve. Finding my x, my variable, is a multiplication and then an addition. So I'm going to take care of the addition first. So I'm going to subtract 1 from both sides. The 1 minus 1 cancels out, leaving me 2x on the left, and the right-hand side equals 7, 8 minus 1. We divide by 2 to isolate the x, so x equals 7 halves, which also equals 3 1/2. And again, I can put this back in the original equation to check it. I have, and I'm going to try the story problem. In this case, I want you to read this problem carefully. I want you to realize that you need 5 sheets of construction paper for the title banner. That is a constant. That's not going to change. So that's going to be your constant. You have 18 sheets of construction paper total. So that's your total amount. You plan to use a half a sheet of construction paper for each ad. So you're going to have half a sheet for each ad. That's the part that's going to change. If you have 1 ad, you're going to have half a sheet. If you have 10 ads, you're going to need 5 sheets. So that's the part that's going to change. So I've now set up my equation. To solve this, I'm going to realize that my variable is multiplied by 1/2 and added to 5. I'm going to undo the addition part first. So I'm going to subtract 5 from both sides. Let me get a slightly better color. Notice I'm keeping the equal sign in the middle here to keep my equation balanced and to keep myself organized. So on the left, I have 1/2 a. The 5's will cancel out, equals 13. Now to get rid of the 1/2 a, I'm going to multiply by the reciprocal to make it 1. I could divide by 1/2, but multiplying by the reciprocal is going to give me the same thing. So I'm going to multiply both sides by 2. 2 times 1/2 is 1, so I have 1a equals 26. So a equals 26 in this case. That's how many ads I can make with 18 sheets of paper. And I want you to take a moment and think about this, how you would solve this. When you solve this, you would look at this part of the equation first. That's grouped by that division sign underneath. So in this case, order of operations say subtract 3, then divide by 4. When you undo that, that means you're going to undo the divide by 4 first. How do you undo divide by 4? You multiply by 4. So those cancel. So on the left, you're left with x minus 3 equals 8 times 4 is 32. Now we're going to add 3 to both sides. Again, keeping that equal sign nice and lined up to keep myself organized. And x equals 35. Let's take a moment and try this one and make sure that it is the true statement. So I have x minus 3 over 4 equals 8. In the x spot, I'm going to put 35. So 35 minus 3 is 32. 32 divided by 4 equals 8. Well, of course, 8 does equal 8. So I've checked this. X equals 35 is my solution. We will do plenty of these in class. So if you have any questions, make sure you bring them.